This is going to be part 3 in the series of tutorials for completing our Throw app. And in the previous part, we got as far as step 34, where we created a block, and it says that in step 34, which I hope we already did, is to add a script called single block. Make sure that you use this exact name, capital S, capital B, and once created, to save it into a My Scripts folder in recent versions of Unity. When you create a script like that, as soon as you save it, it asks you, where you want to save it. So one way or another, it needs to belong or put in My Scripts folder for nice organization. Then, of course, it starts with a default code, and hopefully before you're watching this part of the tutorial, you already typed this code. I have already. I have a My Scripts folder. I have all the scripts done already, but you are going to have only one script so far. And when I open this script, this single block, let me also make sure I have the script, but I want to make sure that it actually, the script belongs to the block. Let's go over the code in the script because it's very, very minimal. It has only one using, the default one. Make sure, of course, that the name of the public class matches the name of the script. It declares only one public variable, an audio source called myImpact. In other words, what's to play when there's an impact. And there's no start, there's no update, there's only one function, a void on collision enter. The event is collision. The object that causes the collision, I just named it who hit, and it asks a very simple question. If that object that caused the collision, that triggered the collision, dot game object got compare tag ball, if it's the ball that hit me, the block, my impact dot play. My impact, remember, is the name of the audio source, and then end if, end collision, end class. That means that the only thing the block needs to know is who is my impact. Going back here, so when it's asking who is my impact, it's the block itself, because it has an audio source. So block, drag, and it's not the block, but the audio source of the block, as it says in the guide. In the inspector, drag block to the field my impact in the script, so it knows, in other words, whose sound am I playing? My own. Then, once this is done, this block is ready to become a prefab. So I'm going to my prefabs folder. I have already one prefab. The block will become, let me just make sure. Yep, everything about it is reset. It's dimensions and it's transform reset. Block becomes a prefab. And then, of course, I'm going to right click and delete it from the scene, because it's from now on going to be used only to be instantiated as a prefab. And it's literally exactly what it says in step 37. Then we're going to create the wall itself, or to be more exact, the container, which is the wall. It's going to be a game object. Its name is going to be brick wall. Empty game object, brick wall. I'm going to reset its transform, but its real transform is going to be something like this. Negative 4.5, and we're going to see that that's going to change later on. It's just, temporarily, and more importantly, scale 111 and 5 meters Z, which means it's 5 meters in front of us. So, negative 4.5, no, not 45, 4 point. 0.5 and Z5. If I look at the floor plan, as we call it, this object, the brick wall, is right here. Now, it's in front of me, but a little to the left, because it's going to grow to the right and eventually become, centered. The script is going to make sure that it's always centered in front of me, but it's 5 meters ahead of me. Next. We're going to add a script to it, which is called Wall Builder. And once created, moved into the scripts folder. And this might be a good time to pause the video, create that script, type that code, and come back to this video once you've typed the code to see the explanation. So assuming that, if you're hearing me right now, that you actually typed the code for Wall Builder and attached it, of course, or added it as a component to the Wall Builder. As you can see, that brick wall has the script, and it has four parameters, which are listed in the script. So let's go over the script, assuming that you already typed it. It has only 37 lines. A lot of them are comments. Only one library using the Unity engine, and of course the class Wall Builder, same as the name of the script. Like I said, 4 parameters. It's got one game object, what block. In other words, when I build a block, who's the block? And it's of course going to be the prefab we call block. Then public game object wall parent, and that refers to itself. It is its own. It's the parent of all the blocks. Why do we need that? So if we create a wall that's, let's say, 10 blocks wide, we want 5 of them to be to the right and 5 of them to be to the left, so it's always centered. Then width and height is, how many rows and how many columns. I can have a wall that's 5 by 5, 4 by 7, and so on. All of that happens on start. Notice that there is no other function here. Make sure that when you type it that you use start with a capital S. It's a very common mistake. Inside the start, there's a for loop. A loop, we used loops like that in the past, but it's a loop within a loop. Why? Why is there 2 loops? One loop for all the rows, in other words, the first row of blocks, second row of blocks, and so on. And within each row, it goes from left to right, to build the row. So, for, it declares an integer, y, 0, just like any other array. We start from 0. It will keep going as long as y is smaller than the height that we're going to give it, and it's going to increment 1 at a time. And then inside each row, there's going to be a loop that builds that row, x, from left to right. Same idea, starting from 0, keep looping as long as it's smaller than the width, and increase by 1 each time. Within each row, loop horizontal, left to right. How is it going to build that wall? It's going to declare a new game object called new block, the one instantiated right now. And if you remember, instantiate demands 3 parameters or 3 arguments. First of all, what block? Who to instantiate. Then its position. Its position is going to be the wall parent position. It's going to take its position from its parent. It's going to be relatable to its parent. And then its rotation. Again, wall parent, transform, rotation. So whatever position and rotation we give its parent, its children are going to inherit that. New block dot transform parent equals game object transform. Now what does that do? It actually says, not only am I going to take my position from you, I'm going to actually become your child. So it's actually, adopting itself. The new block is saying, I am your child. Make it a child object of whoever object is calling this script, which is the brick wall. That means that at this point, we should have children of the wall, and it's as many blocks as we give it. I'm going to stop for a second, and just to demonstrate this, I'm going to actually skip to the next step after the end of the code and populate all of those fields, and of course explain why. So, what block? I'm going to go to my prefabs and go Mr. Block is going to play what block? Who is the wall parent? The brick wall. And here I'm just going to type a number. Like, at first in the tutorial it says 10 and 4. So it's going to be 10 blocks wide and 4 blocks tall. Later on we can change that. So 10 and 4. Now if I play, here's what should happen. If the script is correct, of course. It just instantiated a wall exactly in front of me. And it has 10 for each row and 4. And while it's playing, I can actually see that brick wall is the parent, and all of those blocks, all those 40 blocks, right? 10 times 4 are its children, starting from here, going left to right. So let me stop. Here's the rest of the code. So this line 17, assigns each block to be a child of the object that is calling the script. So they're all children of the wall. It's very helpful if they're all children of the wall, because then we can, after that, scale the wall. For instance, I could do this. If I instantiate the wall, I can go to the brick wall itself if they're his children, and I can say, hey, why don't you all move left, move right, or even scale up and down, or rotate, and so on, because they're all children of this one object. Going back to the script, new block, this is, the block that's being instantiated right now, make its local position, whatever is x. Remember, we are going x equals 1, 2, 3, 4, and so on until we hit 10 in this case. Y is going to be y plus 0.5. Now, y plus 0.5 because the center of the block, this block is 1 meter by 1 meter by 1 meter, but its center is half a meter, it's in the center. So its center is 0.5. In order for it to sit on the floor and not halfway sunken into the floor, I have to add 0.5 to it. Its z is 0, which is going to inherit from its parent. And its parent is 5 meters away from us. Those added lines that we can use for customizing is to actually inherit some local rotation or local scale. For right now, I'm skipping those lines. Those are experimental. We don't really need them. So this is the end of the X loop. This is to build one row. And once it builds all those rows, once it builds one row, it'll loop through the once it builds one row, it'll loop through the next row. And then y will be the y plus 1. So instead of y plus 0.5, it'll be 1.5, and then 2.5, and then 3.5, and so on. This is the end of the y loop. So this is the end of the X loop, the inner loop, and this is the outer loop. Then a few lines that take care of the position of the parent. Now look at what we're doing here. I want the parent to always be centered. So first let me demonstrate how it's centered. What if the width of the wall was not 10, it was 6? In that case, if I play, I want it to be pretty much like, 3 to the left and 3 to the right. Look at the X. Instead of being -3, it's -2.5. Now, why -2.5? Because it always refers to the center of a block, which is half a meter inside. So we need to account for that. And this is exactly what those few next lines are all about. How do we do that? We go something like this. I want the wall parent's position to be, I always have to declare position always demands, new vector 3 with x, y, and z. So notice that I'm not changing the y. I'm saying basically your position is your y. Your z position is your z position. The only thing that I'm calculating is the x. So this is really what matters. I'm saying something like this. If its width was 10, how would I know what its x should be? I would go something like this. If its width is 10 divided by 2, that's like the center, and then go half of that to the left. So its width divided by 2 minus, because it needs to go to the left, but adds the 0.5 because we're dealing with blocks that their center starts half a meter in. So this way, if it was 10, it'll go, okay, 10 divided by 2 is 5, making a negative 5, but it needs to be negative 4.5, so it ends up exactly in the center. This way, it'll work for any number that I have. What if the width of the block was 9, an odd number? When I play, sorry, not 6, to stop. What if it was 9? It would go, okay, so 9 divided by 2 is 4.5, but add back the half, it's negative 4, not 4.5, and it's perfectly centered. That way, no matter what the width of the wall, it'll always be perfectly centered. Even if it was 1, like a little, tower, look at what it'll do. If it's 1, then it needs to be half a meter. Actually, 1 is exactly, in the center because it already accounts for that half a meter. If it was, let's say, 13, it would divide 13 in half and add half a meter. Divide 13 in half is 6.5, but drag it to the right half a meter, negative 6. It's always going to be negative because everything starts from the left with a correction of half a meter. Continuing. Don't forget to stop before advancing to the next step. So I'm going to return it to the default, which is 10 by 4. Next, now we're going to build the reset button, and we're also going to give it a reset script. I think I'm going to do that on another tutorial. So I'll see you in the next part.